Hello, this is Eric speaking, and this is another video on the foam channel, but we're not going to be talking about foam today. We're going to be talking about ES6 features and also that they're all syntax sugar. Syntax sugar refers to a language feature that doesn't actually add any additional functionality to the underlying language, but changes the grammar so that you can maybe type something with a more convenient syntax. The examples that we're going to go through in this video include arrow functions, promises, and async await, which are the same thing, and ES6 classes. We'll start with arrow functions. So what we see on the top here, the comment syntax sugar, is an arrow function. It has no arguments and it does nothing. Below we see the equivalent underlying JavaScript code, which is we have a traditional function literal, and we're binding this. So what this will do is this will become the this in this function. So this here is the same this as that this. I hope I've also demonstrated that the name of the this keyword can be a source of confusion. It might sometimes be better to just call it the instance object. But the most important thing to know is this is a shorthand for this code here. It is not a shorthand for this code here. These will behave slightly differently. So let's look at this example here. We have an object called myObject, and it just has a member name whose value is Fred. And we define a method on this object called method1. So we make our function literal here. And we're going to define two functions inside here, a and b. The contents of the function are exactly the same, but our output is going to be a bit different. I'm going to run the example here. We see that it prints undefined, and then it also prints Fred. And now if I wrap this function literal that we're calling a in parentheses, and I bind this, well now, like I said, this is going to be the same this as that this, or rather, the this that we have in this function here. If I go and run that, now it's going to say Fred twice. So without our bind function here, or without calling bind on the function, what is this? Well, let's try logging the evaluation of whether global this is equal to the variable named this. Yeah, sure enough, if the function's not bound to anything, it takes global this by default as its instance object, and if it is bound to something, then it'll have that. So we can bind that to something. Let's make a new object inside here. So we've made an object with the member name having the value Sarah instead, and we've just assigned these names on that object to the same functions that we already defined here, making them methods on other object. So now we're going to change these calls to call our other object instead. So let's see what happens when we run this. Now it says Sarah and Fred. Our log on whether the instance object is equal to global this is now false on both of them. Once bind is called on a function, or once a function is bound, it cannot be bound a second time. So that's why our b function here, it's still saying Fred, because the arrow function implies, as we've seen before, that it's bound to this. So for example, that bind this was called on the resulting function. That's something to be aware of, and it can be very convenient to use arrow functions, where in other situations you might have to do something like this. Define a new variable and refer to that variable inside that function. So we say self.name. I'm just going to point to that. Let's see what happens when we run this. Okay, cool. So we have the value Fred, and we're accessing it from that function simply because we're using the lexical scoping property of JavaScript and not relying on the instance object. Okay, we've looked at arrow functions. There's nothing more to say about them really. And now we can move on to promise and async await, which as I said are the same feature. Or rather, async await is a syntax sugar on top of promises. But we're going to look at promises first. Here we have code that creates a promise object in two different ways. The first is we call promise resolve, which just returns a promise that's already resolved to a value. So in this case, it'll be a promise resolved to 1. And that means if we call dot then, it will immediately call the function we pass it and provide that value. So value is going to be 1. It's just going to say first 1, 1. The second way that we define a promise object is using the new keyword in promise. It takes a function as an argument. The function can call things asynchronously or do whatever it wants, passing this resolve callback along the way. And the value we provide when we call resolve is going to be what gets passed down here. So we have our then, and value is going to be 2. So not especially interesting. Now we can do something like this to show the ordering of promises. So we define two promises as functions that call setTimeout and resolve after a random amount of time. So we'll see that sometimes first one is first, and sometimes second one comes first. It seems to prefer first one being first most of the time, but I think that's because it's seated on the current second of the timestamp. So I would expect to get the same ordering if I were to run the program multiple times in the same second. So now we look at the async syntax. We have the async keyword before this function, which means instead of waiting for a promise to resolve, we can just call await. So instead of saying promise1 dot then console log, etc., we can write this a bit shorter. But one thing we'll notice is that we actually always get the same ordering of these two outputs. We also see this main was called log get printed first before anything else, which is interesting because we call that after main is complete. But main is an async function. It in itself returns a promise, and we're not waiting for that promise. So if we were to do dot then this will appear at the end. Just like that. It's important to note that even though this function doesn't return anything, the fact that we've included the async keyword implies that it returns a promise object, and it always will. Let's move on to the next thing. So we have two different functions. One is called sequential and the other current. They're both asynchronous. In the one called sequential, we call console log await, and this time instead of having a promise value, we have a function that we can call that is going to return a promise. What makes this sequential is the promise will not be created on the second line here until the first promise has resolved, which means we're going to see these console logs up here appear always in order and always in between these console logs over here. In contrast, we have a concurrent implementation where we use this promise.all method that's built into the language, and we pass it an array which will contain 3 promises. We create all of our promise objects at once. Presumably we're doing some behavior that can happen asynchronously in the background, such as reading from or writing to a file, um, listening to a WebSocket, or handling an HTTP request. Now all of these tasks outside the sequential JavaScript environment can happen simultaneously, and once they're all complete, we're going to enter this loop here. This is just our main function. It's an async function that just executes both of them sequentially. Let's run that example, and we'll see the sequential version prints started timer for 1, for 2, etc. Before each of the respective console logs. And then the concurrent version, it starts all the timers, and then we do our console logs at the very end. And again, that's because this second line here, this doesn't execute until this first await has already resolved, which is happening right here. I mentioned earlier that the async await syntax is actually a syntax sugar for promises. So this would be an example of the difference between the syntax sugared code and the real underlying code being executed. We make an async function that returns 4, and in the example below, we make a function that returns promise.resolve, and we pass it 4. And if we were to return nothing in this function, as I mentioned before, that is the same as returning a promise that resolves to no value. And the console log await that we see up here would be equivalent to if we had done example.then and then passed our value to console.log. In a more complicated example, you can see why the syntax sugar would have been added. These two functions do the exact same thing. The only difference is this one uses chaining with .then. Sometimes we return a promise, which is going to actually allow us to call .then again on whatever promise was returned. And then we return 4 at the end. But because we were doing this in the callback to a promise, this is actually going to be what the entire chain resolves to. And finally, very briefly, I'm going to talk about ES6 classes, just to demonstrate that it's a syntax sugar on underlying functionality that's existed in JavaScript well before that. So we have what you'll recognize as an ES6 class, a constructor, a method, and a getter. So this is going to say, hello Casey, and it's going to grab that from this instance variable and this getter here. Now the same class can be represented this way. We create a function, and this function is going to call object.defineProperty. This will allow us to create a member on this, which is the instance object, with a getter. So that's something JavaScript supports natively before ES6. And this .greeting, that's just our constructor that we had in the original class. Then we add a method to what's called the prototype. So anything on the prototype of a literal function is going to be bound to the instance object whenever such an instance object is created. So we say O is equal to new sum class, O.sayHello. Say hello will be bound to O, just like it is in this function. So we should expect these will return the same, or they'll print out the same thing. And they do. And that is it for these specific ES6 topics. If you already knew all of this, that's great. And if you didn't, now you do. And if I went too fast, please let me know. and let me know what I can dive into a bit more.